Are we ready? You're recording?
Yep.
Wow, that's great. Well, hello everybody. Welcome to our session here on blockchain. My name is Russ Fustino. I'm a Technical Evangelist at Algorand. I've actually been doing the evangelism role for, over 20 years. I've been here many times at Silicon Valley Code Camp. And how about we give a nice round of applause for Peter and the whole crew for what they've done here. Amazing. I love it. You know, by the community, for the community, right? That's it. And I go to code camps all over the country. I like the one out in Fort Lauderdale. It's in February. It's a good place to boondoggle if you're wondering, you know, for the winter months when it's cold. I actually live in Tampa, Florida, and I have enjoyed this role quite a bit in the last 20 years with, and also I'm a book author too. Last year I published a book on Azure and Xamarin Forms. And this is a very exciting session we have on tap for you today. And I'd like to go ahead and introduce our team here. Where's Victor? You want to say hi, everybody? He's in the back corner there. Hello. And so he's out here from Algorand as well. And let's go ahead and get into it here. So what we're talking about is a borderless economy and boundless opportunity. Algorand is defining the standard for blockchain technology. And before we get much further, I'll let you go ahead and take a picture of this or scan the QR code. We're going to do a drawing at the end of the session worth marvelous prizes. We have a $200 Amazon gift card. So if you just go ahead and go out to the algorand.com/developer-entry or take a picture of that and go out there sometime during the session. The QR code should work as well if you got a QR reader, and I'll bring you to that same site. And we'll give out a $200 Amazon gift card when we're all done. So we have the goods. I'll show you next as soon as we're done with my zooming in on that. Right. We'll talk a little bit more about that over the course of the session here today. All right, anybody still need that up? We'll show it again at the end, but I think most of you got that. So let's go ahead and continue on. So this is another good one to take a picture of. The PowerPoint is available at that middle URL that we're going to be using here today. Also, all the code I'm going to be showing you is at that top link, the GitHub, Algorand, DevRel. The flyer you may have seen has GitHub misspelled at GitBub. That's the new subsidiary for GitHub, I guess. No, it was just a typo. So it's github.com. I think most of you figured that one out. Algorand-DevRel, and then you'll see a bunch of projects there. Hackathon is the one that has all the source code for the demos today. So I like to show that right up front because people always ask about the source code and also the PowerPoints, as well as some other information. So let's go ahead and get started. So who here is excited about the blockchain promise? Anybody out here? We'll get you jazzed up here today. It's a very exciting time, right? How many are fairly new to blockchain? Show of hands. Just about everybody here. Who here has actually helped build a solution on another blockchain or has experimented? All right, good. What did you use? Which blockchain?
Smart contract for Ethereum.
Ethereum, okay. All right. That's a very strong developer tools, right, with Ethereum. And Algorand will follow suit at that, too. We'll have some good tools as well. That's good to know. And anybody here have ever heard of Algorand before this code camp? A couple of you have. Oh, okay. Very good. You don't count. Oh, that's good. Also, how many developers we got out here? Show of hands. Probably about 60%, 70%. Okay. What languages are we using out here? How many are using JavaScript? How about Java? C#? Good number. Any other C flavor? Okay. Python? All right. How about Go? All right, good. We got some SDKs in most of those languages, so we're showing you those as we go through here today as well. And so basically, the blockchain promise is this. It's tamper-proof because it's a mutable ledger, and it has transparency because all transactions are public, and there's trust, right? There's no central authority needed. So I think what's been happening is a lot of the news has been, having these different, ransomware attacks, right? Have anybody heard of a ransomware attack lately? And one of the reasons for that is the centralized data. They figured out a way to get into the data store and expose it. And there is actually, this has been on the news quite frequently, to be honest with you, over the last several months. And over 25 cities have been held with ransomware attacks. Baltimore was one of the more recent ones, and a lot of other cities as well. And they had to pay $100,000. So what is worse than a ransomware attack? I think I exposed the answer there. Everybody catch that? What do you think is worse than a ransomware attack? What did you say?
Data breach.
Data breach, not bad. Any other guesses? Many attacks. I like both of those. We'll give you a shirt for both of those. All right, so there you go. Whoa, ready? Can you catch it? Give it a shot? Yeah, all right. Good. I haven't lost a baseball arm yet. All right, so what's worse than a ransomware attack, in my opinion, is ransomware paid, right? And there could be a debate on that, but actually over near Tampa, Florida, where I live, in Palm Beach, right across the other side of the state, they paid a ransomware attack, and I saw it on the news, the local news. I couldn't believe it. The citizens were irate, because that opens up the door to what? Another attack, coming in. But then again, it could have been mission-critical data. They had to get it resolved, and that was the price they had to pay. The mayor said they had, insurance on it, but, get enough of these attacks, and the insurance rate's going to go up, and the taxpayers are going to pay for it anyway. So these are things that are happening, seeing more and more, and that was actually to the tune of $600,000. And it's really tough, and I think, what we're talking about there, the crux of that problem was centralized data. And the other thing is identity theft. Who here has had identity theft happen to them? Anybody? A few of you have. All right, you know someone, right? This is becoming more and more of a problem. I know my bank has called me a few times to change my debit card, right? Because they felt it was hacked. Well, how? I'd ask, how did this thing happen? How did it get hacked? And they never, tell you how it happened. But what happens when you swipe your card at Starbucks? Well, you go through a front-end processor, then an acquiring bank, then card association, issuing bank, payment processor, Fed Reserve, and a clearinghouse. So that's like about 7 different middlemen in that process. If any one of those has a security breach or a problem like a ransomware attack or whatever, your DNA is now distributed, right? It's out there in the world. So this could be part of the problem, right? That you have so many players involved, and it's something that's happening more and more. Which leads me to believe that some things are broken, right, in the financial community and the way we do things today. It's amazing that you can talk pretty much instantaneously over the internet around the globe, but to do a financial transaction sometimes takes several hours or days, to complete. An alarming statistic that we found here is the erosion of trust, and this is 92% of the millennials do not trust centralized financial institutions. 92%. To me, that's an alarming number, that there's been something wrong that's happened to them already, or they've read about it, or people that they know. A big thing, too, is lack of access to modern financial services. Over 2.2 billion people on this planet do not have access. A lot of the banks and major institutions, it's not worth their while to do small transactions to remote places. And but that accounts for a lot of folks. And then to make matters even worse, cost inefficiencies. They're 6% of the global GDP is transaction costs, and that represents $4 trillion. Are you with me so far? All right, so now blockchain basics. Let's get into the agenda, what we're going to cover the rest of the session here. We're going to cover the basics. We're going to talk a little bit about what Algorand is, what our consensus model is, as well as Algorand Foundation and testnet and mainnet networks. We're going to end with some code. I'll show you a lot of good sample code and RCKs to kind of build solutions on top of the blockchain, and some things we got coming up. So start out with the blockchain basics. So a core characteristic of a traditional database is that it has a central authority that governs it. Now, I used to be a DBA at one point in my career, so I controlled who had access, what types of data they can have, what is stored in, what is deleted, what is archived, and so this has at least 2 potential flaws in it. First of all, one master database with one major key holder for each organization, and this can result in a single point of failure, and that's the important point, a single point of failure. A second major flaw is that all the power is held by a central authority. Now, in general, that might be okay, but what a central power can do, however, is exert authority that is subject to bias, and such as limiting access for subjective reasons. So again, you have a few problems with that. So what we want is this: something that's distributed, something that's secure, and basically an efficient ledger. So how do we do that? Well, with our blockchain, which you see here, is you got a sequence of data organized in blocks. Now you can think of a block as a record, and you can think of a blockchain as a distributed database that's read-only and write once, right? So it can be read by anybody. It's writable by all to create a block and add it to the blockchain, and it's tamper-proof for all. So the thing is, you have a hash between each block that gets you to the prior block, and you can detect very easily if the chain has been tampered with. So very secure. Some of the other properties on blockchain. You have global instant access, tamper-proof, append-only log, cheap to do transactions and share information. Our transaction rate for our algos on Algorand's blockchain is less than a penny a transaction. So compare that to the 28% that you're paying on credit cards. It's a very small amount of money, right? Also, absolute trust and accountability. So it's virtually impossible to break the system, and that's another very important point about security. So what's the blockchain good for? What was your application you used blockchain for with Ethereum, if you don't mind sharing?
I made a little experimental thing with Hive.
Okay.
To basically record, I would encrypt and record, let's just say, data points, and then store the data in the Hive.
Oh.
Basically pointers to Hive.
Okay. All right. Very good. We also had, I think, we had a hackathon I'll tell you about in a second with some really good applications. But generally, blockchain is good for anything that's got to be notarized. Anything where you got to have an audit trail. It's built right in. Right, it's baked right in. You can see all the transactions; they are public. It's great for payments, cryptocurrencies, right? Anything financial, supply chains. Another very good example. I had a hackathon up in Boston a few months ago. The winning team actually they called themselves Algo Med, and it was a supply chain type implementation where they tracked the medicine that gets distributed from the manufacturer to the supplier to the distributor to the pharmacy to the patient that requires it, because you get medicine in the wrong hands, it can be deadly. So this is another great example of where a blockchain application really is very, very good. Other types of applications, authorization of identities, voting, great, right? We have a lot of problems in voting, it seems, and no matter where you go on this planet. There's always an inconsistency. There's always double voting is happening, things like that. And blockchain, once you cast a vote, it's out there, it stays, and that's it. So it's very, very good application for that. IoT applications, you can actually install an Algorand node on a Raspberry Pi. It doesn't take a whole lot of energy to do that. So think about that. If you got sensors that you need that are related to an application, you can have that right in your node and have instant access to the network, to the Algorand blockchain. Great for digitization and tracking of assets and records like card titles, birth certificates, degrees. That's all really a great application. Healthcare record keeping. Boy, would I love when I switch doctors to have all my healthcare immediately accessible, right? And say, okay, here it is. It's on the blockchain. There's everything you need to know. Waste management tracking systems, cross-organization transactions, billing. These are all good examples. At the last hackathon I helped out at, it was up at Waterloo in Canada by Toronto, University of Waterloo. It was Hack of the North. It was, I think, the largest hackathon in Canada, 1,500, primarily students doing the hackathon. And we had our first and second place teams. The first place team was called the Algo Fund. And what they put together was a solution for GitHub as a encouragement for people to solve problems on GitHub, and because they experienced cases where they were stopped at a particular bug and they couldn't get anybody to look at it or fix it, and a couple months went by, so they were frustrated with that. And it says, you know what? How about if we encourage people to do it, and we'll give them, algos to help out if they solve a particular issue. So they put a system together to do just that, to be able to integrate. They integrated with GitHub, and they integrated with the issue tracking that's in there. And when something got resolved, there was a link that they go ahead and entered their information in. They create an account and tracked it that way. The second team was a donor chain. So that they had a map of the globe, and anytime somebody had like an organ to donate or something like that to donate, then they'd be able to see that on the map, and they tracked all that through blockchain. So very interesting ideas around the whole block space stage. And I think you could see there are really more domains in this, but these are probably the really ones that stand out, like right away: healthcare, real estate, communication, government records. Real estate, for example, we got asset blocks, right, over one of our partners in Boston. Our company's based out of Boston, and they have, say they own a hotel, and they want to kind of split up the ownership amongst many people on this. Well, you can have certain assets of that particular hotel divvied up across many people through the blockchain. All right, so again, the traditional things that you don't think of, but these are now facilitated through blockchain. The last piece here is very important. So this goes over public and closed, and public and open and private. So a public blockchain is referred to as a permissionless blockchain. And on the other hand, a private blockchain is a permissioned blockchain. So when we talk about public blockchains, what most people are really talking about is a public open blockchain. It's a blockchain where anybody can write the data to the blockchain, and anybody else can come and read that data. Public blockchain platforms include Bitcoin, Ethereum, Litecoin, and now Algorand. And we also refer to our permissionless blockchain platforms, and meaning that they really strive to, by design, increase and protect the user's anonymity. But basically, you can always use open public platforms to build a permission solution. You just need to be aware that it's upon you, your architects, your developers to create that permissioning model, and all that starts with some kind of identity management system. So you take a look at the bottom left corner there with construction and defense. You would typically not think those might be appropriate applications for blockchain, but really they can be with what we call a layer 2 solution. So basically in Algorand, we have a note field that is freeform. And so any layer 2 app can build anything permissioned that they want. And Algorand will not enforce any permission rules, though it has to be done in a layer 2 app. So we'll see this layer 2 app done in use of the note field in the very first demo that we do today. I've got a chess game, and we actually write in the every time there's a move, that's a transaction, and we store the state of the game in a structure in the note field. So it's very application specific, but you have that to use to make your application do what you want it to do. Questions so far? Far so good? All right. So what is Algorand? So borderless economy is the big ticket, right? So think in your mind, now I could do transactions all over the globe without restriction to borders. And it's between who? A sender and a receiver. And there's no middlemen, which is beautiful. And so that really makes it simple to do transactions and direct. Also, borderless, transactions come into play, borderless, applications, development, finance, and the list goes on, what you see here in the way of borderless opportunities. And who is Algorand? Well, at the very top, the original founder of Algorand is Silvio Macaulay. And Silvio won a Turing Award. For those who aren't familiar with that award, it's like a Grammy in the entertainment industry, but in the computing field. Very prestigious for his work in cryptography. He's an MIT professor he's a professor at MIT. I think Victor actually took a class from him or knew him over there as well. And he says that today there's a massive opportunity to reboot the financial systems of the world, and that is so true. We really are on the cusp of something big there. So it's an alternative blockchain developed from first principles and enabling continuous progress. And specifically, Algorand is a pure proof of stake consensus, which I'll talk a little bit more about. It scales to billions of users. Blocks are blazingly fast, right, to create them in 5 seconds or under. Transaction throughput is really fast, 1,000 transactions per second. And as I mentioned, the cost per transaction is under a penny for every transaction that you make. So let's talk about the consensus and really what's going on in here. Let's talk about the Byzantine agreement and really what's going on in the blockchain. So here you have the blockchain all connected. Anybody here also use Bitcoin or Ethereum? A few of you, I know you have two, I hear a little bit. So you have something called forks and proof of work, right, in those blockchains. Not the case here in Algorand. We have no forks, we have one continuous blockchain and no proof of work to determine the next block that gets created. Instead, we use math. We use a verifiable random function to determine the next block, and this is how it works. Basically, it starts out with the Byzantine agreement. Now, who here is familiar with the Byzantine agreement? A couple of you are. For those that aren't, the way it starts out was a story about the generals. They want to communicate what's going on before they attack amongst all the generals that are on the outside here. If any one of those or multiple of those do not get the correct message, and then they, which could happen for any reason, could be bad weather, could be corrupted, could be anything, and maybe the message doesn't get through. And if it doesn't, and they decide to attack, and they think, well, we got everything we need for everybody, but maybe two of the armies don't have supplies, you're going to fail. And this is not going to work. And furthermore, it doesn't scale, right? It only goes to like about 20 generals or so where this breaks down. And then I was actually talking to Derek, one of our mathematicians at Algorand. He started teaching me about isotonic computational complexity, which is a function of something, how well something scales versus the cost. And so, you get things like linear functions where you double the people, it doubles the cost, but many are quadratic functions. And so if you get 1 million people, right, that's 1 million squared, in the cost, which becomes really unsurmountable. So Silvio figured it out. You really don't want everyone to participate. What you need is a representative sample. And that sample, cryptographic unicorn, is referred to as a verifiable random function. So that's been open source. So you mix that with the Byzantine agreement algorithm, and you end up with a scalable agreement on how transactions are processed. It's a low cost, it's green, it doesn't take a lot of energy, right, to build the blocks. It's very efficient, not like anything the overhead with mining blocks. So specifically, the pure proof of stake consensus then is public and permissionless, like we talked about. All users can participate. No need to delegate. So there's a delegate proof of stake you may have heard of as well, where you get some delegates that are nominated to do the voting process, right, to create the next block. The problem there is it's subject to denial of service attacks because they are known ahead of time who they are. Bonded stake. That's another term you hear sometimes, and what that is, the participants actually put up money on the table to participate. And of course, if they are a malicious player, they won't get the money back. So you think that might be good, but it depends on what the intent is, right? If they put up $1 million, but they stand to gain $1 trillion, that's a piece of cake. That's a little piece of the pie. And again, they're known ahead of time, so that could have a denial of service attack. And what we have is a minimal compute required. I'm running a node right on this Mac. Like I mentioned before, you can run nodes even on a Raspberry Pi. So the key idea is this. Basically a sample of a small committee, a random set of users. Out of a random set of users is selected. And the committee agrees on a block of transactions, and every member then verifies transactions and digitally signs it. And then the block is added to the chain. So it's like a lottery system in terms of the selection process. And if you have algos, you're in the running for being selected as node for the process. And then it goes through the same cycle once again. Another overview of this is basically here, one account is chosen to propose a block, and then a committee is chosen to soft vote on the proposal, and a new committee is chosen to vote on certifying the block, and then finally the block is written to the chain. So really it comes down to two things. Once again, the Byzantine Agreement Protocol and the random sampling of verifiable random functions. So we have open sourced our entire blockchain code. It's written in Go. That's up on our GitHub site for Algorand. And then also the VRF code we have open source. Question?
So on that slide, you said committee chosen, but it's also a random sampling. So which one is it?
Well, this one right here?
Is the committee chosen, or is it like randomly picked?
The first committee chosen is randomly picked, and then the next committee is chosen is also randomly picked. So those users are not known ahead of time. They're known after the fact, so that reduces the chances quite substantially for any denial of service attacks.
Does the committee have to, does a person have to look through the block and sign it, or is it just like a key signs it?
Well, it's automatic. I mean, it's all done automatically. It's really not somebody, somewhere managing who's voting where. So yeah, I mean, it's all done. It's all automated. I mean, it would have to be to do blocks that quickly in under 5 seconds. Yep. That's cool. All right, good question. All right, another one, yep.
What would prevent somebody from, transaction cost is so low?
If I want to search something, will that be a performance issue?
So I'll talk about that in a little bit. There are some certain options you can have in your node to do indexing or archive, and that really facilitates searching. In fact, the chess example I'm going to show you uses that. What else did I want to say about that too? The speed at which, a proof of work, block creation is about 10 minutes, just to give you a comparison for those that are kind of new to that. So 5 seconds versus 10 minutes, right? So right off the get-go, you're way ahead. And even 1,000 transactions per second is not bad. I mean, I think Visa and MasterCard get about 10,000 right off the bat. So right out of the box, you got some decent throughput, and timings. All right, so let's continue on here with the Algorand Foundation, what that's all about. So I myself work for Algorand, Inc., as does Victor, and we are the technology side of the house. And then there's the Algorand Foundation. They handle all the money-related things like the token dynamics. So this is taken right from Algorand.foundation page, the token dynamics. You can see they're going to do a distribution of a total of a maximum of 10 billion algos. We actually had our first auction a few months back. I think they sold about $60 million worth of algos in about a 3-hour period. So we are on the exchanges right now. Algo's cryptocurrency. The thing I want to point your attention for this room primarily is the bottom line there. There's 250 million algos that will be distributed as end-user grants. That's primarily geared toward the developer community. So we need you to start building solutions, and you're going to need algos, right, to put the apps into production. And that's what's going to fund that. So there'll be more details coming out on that soon, but that's kind of the breakdown in terms of the rewards. So let's talk about testnet and mainnet. So we have global presence worldwide for both our testing environment, which is called testnet, and then mainnet, which would be used for production purposes. We have a lot of tools. I'll be showing some of these live, one of which is the Algo Explorer, which can be used not just for testnet, but for mainnet as well. So you can search by transaction, by block, or by address, account address. Very easy to get going. To install your node, you go to developer.algorand.org. It'll probably take you about 10 minutes or so to spin up your first node. There are 3 modes of operation for participation nodes. One is a normal, which is only the 300 latest blocks are on disk. You can set up properties like I alluded to just a little bit ago on archival and indexer. So the archival stores all blocks in the disk, but can search only transactions in 1K ranges. And then there's an indexer, which you have quicker searches and unbounded ranges. So additional API calls are available with 2 additional calls there. So you can configuration of nodes. You can see the documentation there too, and how to go ahead and configure those. There, I think, for example, when you configure a node, it automatically points to to mainnet. And as developers, you primarily want to really start out with testnet. And so it's just a matter of swapping a couple files, and then you got that fixed up. But there's documentation on that over there. I do want to mention PureStake is one of our partners. They do offers APIs as service to both testnet and mainnet. There are no sync times. All our instances are already synced. And so those are, there's no node installment requirement. They basically have the nodes, and then it's configured with archival and indexer capabilities. High availability, 24/7 by 365. They have API examples for all of our SDKs. Also, the code in the hackathon repository I told you about also has code in there. It's commented out for PureStake and points to a hackathon instance. So when you go to run your node, create your node for the first time, here's what's going to happen. You might be able to get a block in some calls, API calls, but when you go to do a transaction, it may not be working at first, and that's because it hasn't synchronized yet. It takes a while to synchronize. As soon as you start up and spin up a node, it could take anywhere from 8 to 12 hours, right, to synchronize. So in the hackathons in particular, that's a problem because you only got 36 hours typically for the weekend, so you don't want to be waiting for the 6. So we have a special instance set up, as well as you can use PureStake as an option after you've installed your node. Just switch over and point your code to those other instances, and I'll show you where to do that in the code as well. And then, once you are up and running your synchronization time, you'll see in the status comes back, it should be at 0 pretty consistently, and then you know it's all synced up. And we are working on enhancements coming up to speed that up as well. So that's down the pipeline. So let's talk about the process architecture a little bit. We get into multi-sig accounts first, and this is where you can have multiple. You can set up a threshold level. Like a good analogy for this is you go to a bank to get cash a check, and it requires 2 signatures, right? So that's a multi-signature transaction. Think of it the same way here. That Algo team in the first hackathon I had mentioned with the supply chain example, that's exactly how they did it. They did it through a multi-sig arrangement, so they had to get a check off each step of the way. Then we have 2 daemons. One is the KMD daemon, which handles interaction with all spending keys. In other words, this is used primarily for wallet transactions. And this would be the online wallet that's available through the blockchain. Also, AlgoD is the one you're probably using more often than not, and that is the one for processing the protocol and interacting with the SQLite, which is where the data is stored, to record a ledger. And, for those that are brand new to blockchain, really what you have is everybody's got access to the same database. And that's what really makes it beautiful. So your node is actually downloading the database. That's why it takes some time to sync up at first. But you have access to it, and everybody does. So that's really what a distributed database is. All right, so this is a nice chart here. This shows all the methods and properties and classes that are in the blockchain accessible through Goal, which is our command line tool. So you can see here for accounts, for example, you got things like, what are the rewards for the accounts? What's the balance? You can do list transactions, like list the accounts, create a new account, create a multi-sig account, delete and manage and export. All these operations are available at the account level. At the node level down here, you can start, stop, you can clone. These are all available as well. This network is referring to what's called our private network, and it's really, the way I like to consider that as a personal network, and you can start and stop and those right on your machine. So it doesn't go any further. It doesn't go out to testnet, it doesn't go out to mainnet. It's just local right to your machine. I have a slide on that coming up as well. And then you can see the different objects there with wallets, with the ID, and a few of the other classes. So the private network, like I said, I think is more as a personal network, and this is good for developers to learn from. And you can actually test out all the APIs as well with the private network, and very simple. You can create, delete, start, and get status from the private network, and you'll see the directory structure gets created right on your machine when you create a private network. Again, think personal network, think, for developer only, for development purposes, all right? A lot of developers like to use that to get started with, and then they'll go out to testnet and continue on from there. All right, get to the really good stuff here now in SDKs and Swagger. So we have a Swagger definition for all of our API calls. And what that really facilitates is support really in any language. You can see all of those go out to swagger.io, and you can go ahead and import the Swagger file and create, for example, a C# client. Those are using C#. So you're not stuck by any means. If we don't have an actual supported SDK, you can go ahead and do this yourself. We are going to be doing more SDKs as well. And this is how you would download this Swagger file. It's basically just a call out to localhost, and then, or you can use this curl command from terminal. And same thing for KMD. So there's a Swagger file for AlgoD, and there is one for KMD. What's that? It gives you definitions. It gives you name value pairs of all of the method calls with their what's required in the headers, what's required, what the endpoints are. And in fact, you take that Swagger file, import it directly into Postman, and you have everything pre-populated already for testing. It's very, very nice. I like it a lot. A lot of companies strive and take a long time to get to this point. We've had it right out of the gate. Yeah. So generating clients can, and also you have the SDK functionality here with, right now we have Go, Java, JavaScript, and Python. Gives you ability to go ahead and create accounts and manage those accounts programmatically. And finally, we got some really great documentation out of developer.algorand.org. There's actually a good tutorial out there on using the private network, as well as a wealth of documentation on all the API calls. So it's demo time. Let's go ahead and take a look at some demos. Yeah, question?
This is a little fundamental, but you said the process of having a blog, but let's say I got my blog added and probably about
I missed the last.
I got my, so everyone has the same database, and I'm adding my data block.
Right.
And obviously I'm encrypting it before.
Mm-hmm.
So that others can't do it.
Well, the parts, yeah, I mean, the block itself is accessible. You could see from and to transactions, but yeah, a lot of those are all encrypted. Yep.
Yeah. So if I want to now go into my blog and read the data, it is encrypted using a key. But now it's not. It's
Yeah.
not public record.
The blockchain is a public record. Yes.
No, the data inside it.
In the note field, you have the option to encrypt that or not. So anything that you put in there, like I talked about transactions and this chess game I'm going to show you, the players' moves are recorded in there, and they could be encrypted and then decrypted on their way out to display.
The payments are public.
Okay. But what about private data?
Who can decrypt?
Yeah, who can decrypt this question? Like,
How to decrypt the data?
Yeah, as far as note field, that's application specific. So that's all up to the developer on how they do that. So you would know the exact structure that you're writing out and the encryption method that you're using, and you would be the one to know how to decrypt that on the way out for display purposes or whatever in your solution. Yeah. Let me go through some of the demos and see if that makes it a little bit clearer, all right? Because I think you'll see how this all maps. So let's go ahead, take a look here. So I've got two screens up, right? I got this application running. I've got one here that is player one, and I got another one that's player two. So I'm going to go ahead and I've already either generated a player or recovered a player from a mnemonic. I've done that ahead of time. So you can see I've got a player ID up here, and I've got a player ID over here. So what I'm going to do here now is just find a match, and then I'm going to go over to the other player, and we'll do a find a match. And you can see some of the console writings going out. You can see there's a transaction ID, so that's going to be used for the game ID. And now it's trying to find if there's a match. Here's the structure that you can see here on the screen here on the right. And now it looks like player one and player two have indeed been found. And you can see the other information that's getting written out to that note field, and they get populated down over here. You can see player one now and player two in the game ID. So now white to move, and you are the white player. So you want to go ahead and start your move. So let's go ahead and do this. How many people here play chess? A few? Anybody here? Yeah. We're doing it at all my family picnics now. It's a very cerebral exercise, to go through. Yeah, question?
Question, on the right side, are all those algo interactions even before you've made a move, or is that just something else that?
Yeah, there's actually logging that's being done in this application to demonstrate that, to show you what's happening. But yeah, for example, you're going out, you're trying to match a player that's got a request. So it's going to be traversing the blockchain to find who's requesting a match, that sort of thing. All right, so this one here now, it is our turn. You can see the move's been replicated. So let's go ahead and go out here. So now it's going to go back over here. It takes a second or two, and you'll see the move get replicated on player 2. And then we're going to go ahead and do the quick game, 3 moves or less, right, for doing this. So there we go. So we come out here, go back over to player 1, black player, and make another dumb move, like right here. And again over to this player, and we're 1 move away from a checkmate by moving the bishop up. And we'll make one more kind of stupid move over here. Once that move comes through, and then you're going to see the final move on the white side is going to be for checkmate. So as soon as we see that move get replicated over to this side, then we're going to come back and bring it in here. So some of the basic functionality that you saw here was creating an account or recovering an account. Then once you have the accounts matched up, it's going to do some searching, right, for a particular transaction. You're going to create an account, you're going to create a transaction, you're going to write information to the note field that pertains to that particular move. So there you can see black is in checkmate, so the game is over. And what I'm going to do is I'm actually going to run an application that has all the basics, and this chess example is up on that DevRel site. And let's go ahead and fire up another application. We're going to actually walk through the code in this one, which mimics a lot of the functionality that is in the chess game. So here I'm going to go bring up a very simple example to go ahead and get the latest block. So this is going to do a call out. Now you can see all the transactions that are associated with that particular block. And then let's go ahead and generate an account. And let's go ahead and get the account details. Now you can see the actual address of that account. Now notice there is no money in the amount field. So we got something called the testnet dispenser to help facilitate that. So we got like a big account with a lot of algos in it to automatically transfer in testnet to any account you need to seed values with. So we got parking meters here. That's not too bad. Missing any? No, I think I got them all. There we go. So we'll go ahead and dispense, and then you can see a status code 200 coming back. That means it's successful. So now I'm going to recover this account from the mnemonic. So when I created the account, it gave me this mnemonic that's associated with it, and I'm going to go ahead and recover that. And now you can see there the amount field has got some algos in it. And so it did that transfer successfully. The next thing I can do is submit transactions. So I can go from this account to another account. I'm going to transfer that many algos. So I'm going to submit a transaction to do that. So now you can see this transaction, and I'm going to go ahead and get the transaction from the account, which is basically going to show you what's in the note field. And there you can see I've got a structure with just the age, the eye color, the first name, and that's what's going is our free-form note field to retain that information. That is where I stored the chess moves to, by the way, the same place, that note field in transactions. So let's take a look at this code. All right, so here we have the tokens. Let's start out with those first of all. You have a spot here in this code I've got where you can put your own token in. This is your local node that you spin up and your own server and port. Now you find these when you do create a node. Go to my node directory. and there is a data folder in there. So when you do an install, this directory gets created. And then you can see over here is an algo.net. So if I just take a look at opening this with a any kind of a viewer, right here, VS Code. So now you can see that that's going to come up just with your address. And then there's a similar one over here for the token, right? Same thing. And we can show you that as well. And that is actually your token address. So that is what you're going to seed into these sample codes, right? There's the actual token value. So I would copy and paste that in to the application. So this code that you're seeing here has got those values in it. And what I did was I actually am using the hackathon instance I talked about here. That's one that's already synced up. Now, let's take a look at the calls, all right? So here's the call to get the account information. So basically, we're going to create an instance of our AlgoD client here, and this is the account information call that's going to come back and give us that, that information that you saw there. So you can see the IntelliSense come up with all the different methods and properties that are available to that client. So that prints out. Then the next thing, let's get that block status. So that's where it unravels all of the transactions that you saw listed in that output. And again, there is just a very simple call to get the status, and then the block right there to go ahead and get you that last round where you can specify that as a parameter. Question?
Thank you, sir. Did you need a JavaScript extension in VS Code to get all this to work?
Yeah, there's extensions for every one of these languages. Yeah, it's great. VS Code is awesome. Who here uses VS Code? Show of hands. Yeah, it's gaining speed like dramatically. It seems like it's really by far now, I think, one of the favorite IDEs of most developers. Yeah, and so yeah, there's extensions for JavaScript. There's extensions for Go and Python, and I got them all in here. So good question. Then this next section here is on recovering the count. So this is where you take that mnemonic that we saw, and then we're going to feed that in to make sure it's a valid address. And then we're going to go ahead and specify that account information on the way out. So this is the mnemonic to secret key that gives you that recovered account, and you're going to pass in the keywords there. All right, so submitting the transaction, this is where you get the note field, right? And we're going to pass in an encoded person object. And if we take a look at this object, it's defined up here. Right, so that's where we had the first name, last name, John Doe, age. So when we write the transaction out, we're actually going to pass that in as a parameter that you can see specified in the send a raw transaction out to that. And it's going to go ahead and bring that out there. And then when you get the transaction, it's going to do the reverse. It's going to decode that note field, right? And that's going to be what we're going to end up displaying in the application. Make sense? All right. And all this functionality really with a couple lines, 100 lines of JavaScript. How about that? Pretty cool? A lot of good stuff there? Yeah, baby. That's it. So that's one of our SDKs. And then we have the other thing I wanted to show here was, let's go out to the Algo Explorer. And so here you can actually see, we can go wire it up to testnet or mainnet. You can take a look, here's the latest round. So you can actually do a search on that 254, 59, 65 and paste it up there and find it. Also, you can see here's the round, and now over here you can see there's 22 transactions on this block. And then you can see all of the who it's from, who it's to, on the account level. And then if you take a look at the transaction ID itself, then you could see the amount, the algos, the fee, what round, and then here's the note field, right? You can see that this one is encrypted here, and that is kind of like the structure, right, that you go through between accounts, addresses, and blocks. Yeah, question? Right here. So let's click on the sender account. What do you want to know?
The account tied to a device, to a username login.
No, well, it could be. You'd have to set that up externally, right? That was that thing we went over about your authentication, right, up front. If you wanted to do something like that, you certainly can do that, and you'd be using the note field to manage that process.
How do we verify the people creating accounts?
How could you verify the people what?
How do we verify like an account is associated with one person, a real person?
There's a user anonymity. That is the beauty of the public blockchain, decentralized. There's no, really concept of a user ID, in there or a password in there. Everything's open and public. So if you want to incorporate some of that as part of your solution, you'd be responsible for that is really the bottom line. Question? These are, right now, those are looking at testnet, the same thing we got for mainnet.
You did a chess game earlier, right?
Yeah.
Are all those moves, could you find those in?
Yeah, those are in there. I should just copied the, transaction ID when it came up, and I could have pasted it right in there, and you can see that transaction in there. Yep, absolutely. That's okay. Yeah.
What if, let's say, 5 years from now, I mean, I love this idea. I really
Good.
What if years from now it's discovered somehow that 80% of the accounts created on Algorand was from like 20 different people who were building tons of accounts just to pick it up?
So the question is that going to...
100 people from a club, a scamming club, and they create many, many different
Oh, okay. All right.
accounts, show a lot of activity.
So your question is around bad players, right, out there, and how Algorand, will it break, right, if you do something like that?
You can just type it thinking, okay, there's a lot of activity on
Yeah.
the screen, but you realize that's really just 100 people around the world.
The answer is it will not break. At worst case, it would stall the network. That's it. And until a good player is found to participate in the consensus model. No regulators, no. No, I mean, this is
You choose a random sampling, right? And
Yeah.
that's the majority of the people who are actually just bad.
well, you got to think about that, right? So if the majority are bad, that's going to bring down the value of the algo, right? And it would be counterproductive for the majority to be bad because now they're going to be hurting themselves.
I know, but until it's discovered, people don't know.
No, sorry. It's not 80% of the people, it's 80% of the stake.
Yes, yes. So you have to have algos, basically. That's pure proof of stake, and the stake is the algos that are, if you have an algo that will has the potential for participating in the lottery to be chosen in the consensus. Question back there?
When you choose the people randomly or the account,
Yeah.
are those, do they all have to agree, or what if one of them or two of them don't agree, do you pick somebody else, or what happens?
What's the percentage for the agreement? Was it 70% on the consensus model? It's not 100%.
No, yeah, it's, so we're assuming that no more than 20% of the things are bad, and we pick a random selection, so we have specific guarantees. So we're really saying, we require something like, it's actually a computed number, so it's not exactly, but it's something like 75% of our expected committee size. That's what we require. We require votes from 75% of the expected committee size, which we should be able to get, we're assuming that actually 80% are good, right? And so I'm saying expected committee size here as an amount of stake, not amount of stake.
All right, let me get to one more demo because I want to do the drawing, and we're running almost to the end. The last demo I'm going to show you is through Postman. So again, what you do here is you create that Swagger file, you do an import, drop the file in right in here, and then it's automatically going to create structures for you for all the requests, and you can see them all listed right over here. So if you want to do an account status, that there is a call for that. So I actually have one of these up here and running. You can see this is a transaction that's going to go ahead and get the status, and you can see it up there as the endpoint. So the endpoint would be there. Then you just got to populate it with your URL. In the header, this is where you specify the token value name and then the value itself. And I hit the send, and now this will go ahead and bring back that round. So what I'm showing you here is a code agnostic tool. Sometimes you're on a development team that has different skill sets, and you don't know if it's the code that's causing the problem or the API is not working. This definitively tells you whether it's the API or not. And I've used this a lot on teams. For example, I did a UWP version in .NET of an application I wrote for a customer one time, and I was working with JavaScript developers and the rest of the team. They had the JavaScript version, and so I would take snapshots of something that's not working in Postman, and they're easily able to replicate it there. So that's the beauty of this. And then you have a one for AlgoD and one for KMD as far as the Swagger file. This one here is going to go through all the wallets, and they see all the wallet information doing a list. So that is the session. Let me go ahead and bring up the deck again. If you haven't entered the drawing, I'm going to put that information up one more time. And I'm going to go start getting that particular list up here on my phone. And then we are going to do a drawing, and I'm going to do a very, very quick recap as well. So let me go ahead and bring that up here, get that ready. All right, and you got that, you got that. Got that. We got a $200 gift card for Amazon we're going to give away here. All right. Always for you because you asked so many questions. That's good. Anybody want socks here? Who wants socks? That's the question. Who else has the question? Right here. You did. You did. Okay. Oh, that's a good arm. We got one in the back. I'm going to win. Right? Yeah, here you go. Oh, man, did I blow that one. Sorry about that. We have some more at the booth anyway. If anyone wants to come over later, we'll be around tomorrow. All right, I'm going to move on just to get the summary here. So we showed you this slide too on getting the goods. We have our next release going to have a teal script at the base layer 1 functionality. So this will facilitate things like contracts, right? Smart contracts of that nature. Also, it's going to allow you the programmability right at that base layer inside the blockchain itself. We also have atomic multi-party transactions where everything completes or it doesn't, as well as named assets, a very big feature where you can actually create your own currency if you want, on our network. And a lot of other great features there to boot. A little further out, we got things like the vault, right, that's going to talk about that with the solving the storage issues, Pixel, which is addressed to the size and bandwidth of multi-signature requirements. And then also we do have an ambassador program. So if you are interested in becoming an Algorand ambassador, you go out to community.algorand.org, make sure you drop your card off with me at the booth, and we'll go ahead and get that in for you. So you'd be helping out run events here locally and be a local representative. In summary then, we had a lot of good information we talked about here. We started out talking about what is Algorand. We talked about the consensus model. Went into discussion on what the Algorand Foundation is, as well as testnet and mainnet features. Process architecture, we covered all of the different daemons that we had with the AlgoD and KMD daemons, and then the API is very, very healthy development environment. Right out of the get-go, the documentation's great. You can develop in the language of your choice. A lot of great command line tools, and now it's time for the drawing. So let me go ahead and get this